read it.
Jared, you just pressed 2 buttons.
All right, I think what we'll do today, Ellie says hello, is go over the study guide first, and then I've got a Kahoot. I've also got a Jeopardy game if we decide or feel up to one of those afterward. In Google Classroom, I did place, just a heads up, I did place the Kahoot that we would play in class, and I've also got a Quizlet set to review from. So if you want extra review tonight, rather than going through your study guide, you could always, sorry, my screen is frozen. You could always go to Google Classroom from today and look at one of those 2 review materials. Are you making noises? Yes, you are. Stop. What is that?
I can't find it, I'm sorry, because I want to look it up.
Well, what I would do, guys, is if you have any blanks today, fill it out as we go.
Can I just do it on here?
Yeah, whatever, wherever it works best. I mean, fill it out. This is for your benefit, right? Not for mine. So, know and define. What is erosion? What do you have for that, Sanjay?
The removal of particles by wind, water, ice, or gravity.
Yeah, so wind, water, ice, or gravity move sediment or particles that break off of things on Earth or in nature. What is deposition? What does that mean, Ellie?
The laying down of a sediment.
Okay, so when those particles get eroded, where they end up, where they settle out, is where they get deposited. Might be at the bottom of a quarry, the bottom of a lake, possibly at the bottom of a hill. Decomposition. What does decomposition mean? Jaren?
It's when living organisms break down their native dead organisms
Great.
and make soil.
Okay, so I heard when living things break down dead things, and they also mix up the soil.
And
What are
make space for air and water, which help plants thrive.
good? What are some examples of decomposers that you have written down? Sarah,
Worms.
tell me more. Tell me at least 3. Worms.
Snail bacteria.
Good. Snails, bacteria. Elena.
Fungi, slugs, and maggots.
Fungi, slugs, maggots. Any others? Jaren.
Insects.
Insects. Colton.
The roots of plants.
Well, are those really decomposers?
Oh.
Not the roots of plants, no. I think you were maybe thinking about the next one. What is weathering? What's weathering, Noah?
I have a question.
Oh, okay, go ahead.
What's decomposition?
Decomposition is the process by which decomposers break down dead organisms.
When living things break down dead things.
So, yeah, it's the process of those things we just mentioned, breaking down all of the dead living things that were once living, I should say. Weathering is what? What is that definition? Aiden?
The process where rocks or soil erodes down?
Right, and does it always have to be rocks?
No.
It could be anything on Earth's surface, right, being broken down into smaller pieces. And there's 2 types. Let's start with mechanical. What is mechanical weathering? Sanjay.
The rock is broken down through physical changes.
Okay, physical change is the key here. What you start with is what you end with in a physical change. It just might have changed shape, it might have changed size, but it didn't change the actual material. So what are some examples of mechanical weathering that you have in your notes? Luke?
Freezing and thawing.
Good, what does that mean?
It's when water gets into a crack in the rock and then it freezes and expands the crack.
Awesome. What's another type of mechanical weathering? Sutton?
Plant roots.
Yeah, tell me about that. Plant roots.
When they grow, they split apart rocks.
Awesome. Any others? Elena?
Animal actions.
Yep, tell me more about that.
Well, they can like scratch and scrape rock, and they can like dig into rock.
Definitely, and move and weather that rock or dirt. Anything else, Jaren?
Abrasion.
What does abrasion mean?
When glaciers scrape bedrock.
So that's one example. Glaciers scraping bedrock is one example of abrasion, but what else can cause abrasion besides glaciers? Luke?
The wind.
Wind can, water can, and sand, but sand is usually in the wind when it causes abrasion. Under what conditions does mechanical weathering occur faster? So what would happen to basically increase how quickly mechanical weathering occurs?
Like heat and humidity.
Okay, so heat and humidity are actually what speeds up chemical weathering. Heat and humidity speed up chemical weathering. There's one thing that speeds up mechanical. Isak? That's one example, but that's not necessarily what speeds it up. Kara?
Like rain and it being kind of cold.
Yeah, a wet climate. So any place where it's wet or there's rain or there's a lot of precipitation speeds up mechanical weathering. Chemical weathering. What is that? What's the definition of chemical weathering? Sarah?
Process that breaks down rock through chemical changes.
Yes, so unlike mechanical weathering, which was physical changes that break down rock, now we're talking about chemical changes. What are some examples of chemical weathering? Sutton?
Acid rain.
Good. Acid rain. Others? Aiden?
Rusting.
Rusting. Remember, rocks can rust. They contain small bits of metal, which can rust. Stella?
The making of some caves.
Yes, good. How caves are formed, because water can become slightly acidic when it combines with carbon dioxide, and it can dissolve rock. Sarah, what else?
Water.
Yeah, tell me more though. How does water, what does it do?
It dissolves rocks faster.
Great. Anything else? Did we miss one?
Plants' roots kind of give off some acid, and the acid can dissolve rocks over time.
Thank you. Like lichens. We looked at those when we went on our walk around campus. They were on tree bark, they were on tombstones, they're on rocks, even wood on the pavers near the parking lot. So those roots from the lichens can actually secrete an acid which break down whatever it is they're growing on. What affects the rates, actually, what speeds up chemical weathering? What specifically speeds up chemical weathering? Jaren?
Wet hot climates.
Yes, this is where we've got wet and hot, that humidity. Because heat speeds up chemical reactions, and because chemical weathering deals with chemical reactions, we know heat it speeds it up. So wet, hot, humid climates will speed that up. Overall, what affects the rates of weathering? What type of climate? What did we have in our notes? Aiden?
Wet and hot climates.
Anything else? Elena?
The type of rock.
Yeah, so that climate. The type of rock matters because some types of rock will weather a lot faster than others. I almost wrote type of weather. I meant to write type of rock. Any other possible things that you could have had written down there? Type of climate, type of rock. Any others? Okay. All right, moving on then. What is humus? Remember, that's not hummus. What's humus, Ellie?
A dark colored substance.
What is it made from?
Isn't it like limestone?
Well, it can be. It can be partially that, but this is made because this happens. These two are very much related. Humus is made from what, Isak?
An organic material.
Yeah, so that those organic materials or those things that were once living get broken down by decomposers and become that really dark substance in topsoil. Really, really fertile for growing plants. What about loam? What's loam? Sarah?
Soil that is made out of sand, silt, or clay that is best for growing plants.
Right, so if there's equal amounts of sand, silt, and clay, we would call it loam, and that is the best. If you have too much clay, is that gonna be very good for growing plants? How about too much sand? No. Equal amounts of each are what we call loam. What is bedrock? What's bedrock, Jaren?
Solid layer of rock beneath the soil. Once exposed, bedrock gradually weathers in smaller particles that are the basic material.
Good. So again, solid layer of rock that exists under the soil. We talked about the layers of soil being different horizons. And for our purposes, we're just gonna remember horizon A, horizon B, and horizon C. So A is toward the top, B is kind of in the middle, C is down above the bedrock. What are the characteristics of each? Let's start at the top with horizon A. What is there? What is it like? Kara?
That is the horizon of topsoil.
Yep. Which of these things are in horizon A?
A little bit of humus from the layer above,
Good.
which is just humus. Loam, and I think that's it.
Yeah, good. So horizon A also contains topsoil, right? That's the upper portion. What about horizon B? Who can tell me about that next layer? Sutton?
It's clay and other materials.
Yeah, a lot of clay. Is there as many nutrients for plants? No, because the rainwater maybe leaches some down, but kind of the nutrients get leached out of that layer. What about horizon C? What characteristics does horizon C have? Elena?
It's made of partly weathered rock.
Yep, partly weathered bedrock, right? All right, what is the first layer to form out of A, B, and C? What's the first layer that actually forms? Kara?
I don't.
Or did you-
know that down.
Did you have a question?
I have a question.
Hold that thought, let's finish this first. Sutton, what's the first layer to form?
See,
C, yeah, the layer down by the bedrock, remember, was once the top layer. So that bedrock gets weathered and it turns into horizon C. What's the second layer? What do you think is the second layer to form? This might be a little bit tricky. Elena?
B.
Not B. It's actually A. A is the second one to form, because if you think about it, ooh, I'm not calibrated. If you think about it, if you've already got a little bit of soil forming, living things like plants, trees, leaves, other things are gonna start to die on top of it, right? And what do we know happens to those dead organic materials? They get decomposed, right? So actually, layer A forms next, and then what's the last to form? Obviously, B. It spells cab, if that helps you remember the order of the layers. C-A-B. What does fertility mean when it comes to plants? What does that mean? Sarah?
Measure how well soil supports plant growth.
Yeah. How well is it going to allow plants to grow in it? Either it's not fertile or it's very fertile. I'm gonna move this down to finish up the rest.
Chester, a couple days ago at track, they dug holes in the ground to study the different soils.
Really? Where were you digging holes? Over by the track?
No, they were like poking, they made it even, so they like drilled the holes and
Oh, so you could actually see the different color layers, right? Kira, I'm sorry, what was your question before?
how do you say horizon C's name? Or what is its name?
remind me in your notes, how is it spelled? Say it again?
I'm pretty sure it just says horizon.
Yeah, I didn't think that we gave it, I think you're thinking of E possibly, when we talked about there was a horizon E. Illuviated. I didn't think that I gave you a different name. Yeah, check your notes. Noah?
I remember parent material.
Yeah, parent material, which would make sense for Horizon C.
Oh yeah, that's what I have.
Parent.
I think I just smushed it into one.
Oh, parent material.
And I kept very confused.
Okay.
Because in my notes I put it way too close together.
I see. All right, so we talked about how important soil is to us, and really, we depend on soil every day because any of the food we eat comes from the soil, if you really go back and look at the food chain. So, farmers have 3 methods that they use to conserve the soil or save it. What's one of those, Noah? Contour plowing? What does that mean?
It's where they forgot what it was, but they like go along the curves of the land.
Yeah, they basically level off, they follow the contour of the land, like the hills, and they level them off to prevent erosion from happening. Ellie, what's another method?
Conservation plowing.
What's conservation plowing?
They leave dead weeds so they don't chop down the whole thing. They leave the dead weeds to fertilize the soil for next year.
Excellent. What's the third one, Kara?
I can't remember the exact name. Oh, crop rotation.
Yep.
Which is where they switch, like, one year they might have corn, and then the next year they might have peas.
Great.
And they could even, like, probably do, like, 10 different years
Awesome.
of different crops.
Good. All right. Mass movement. We talked about 4 different types of mass movement. It can also sometimes be called mass wasting. They mean the same thing. But remember, what is that? What is mass movement when we're talking about the land? Jaren?
The downhill movement of a large mass of rocks or soil because of the pull of gravity.
Yeah.
Mudslides.
So does anyone remember? Okay, so mudslides was one example of mass movement. What was another? Elena?
The one where like the soil starts moving, so everything keeps moving.
Are you thinking of the fence example?
Mhm.
So remember we looked at the picture of the fence on the hillside that was like this? That's called creep. Because the soil on the hillside due to gravity kind of creeps down and pulls everything else with it. What's another one, Rihan? Slump. Remember, that's where there's actually, it's level ground, and for whatever reason, there's a section of soil that just kind of falls down, it slumps down. And then what was the last one? We said mudslide, creep, slump, landslide. All right, these next few relate to water erosion and deposition. So a tributary, this is probably something you also learned in geo, right? What's a tributary,
A
Ellie?
smaller river stream flows into a bigger
Exactly. It's a feeder stream or river that flows into a larger one. Meander, when you're talking about a river, what's a meander? It's kind of a weird word to say. Sarah?
A loop like bend in a course of a river.
Yes, loop, so it's a bend, it's the loop like bend in a river. What's an oxbow lake? What is that, Sutton?
It is a cut off meander, I believe.
Yes, it's a meander of a river that's been cut off, and we'll talk about that when we get to the pictures at the bottom. And then these last few are all about glaciers. What's a glacier? What's a glacier, Jaren?
a large block of ice.
Yeah, pretty much. Was it always ice?
No.
It started as
Snow.
snow. Good. And they form where? Where do they form? Sanjay?
Continental glaciers only Antarctica and Greenland, but the alpine glaciers everywhere except Australia.
Right. So continental glaciers, he said, are the ones that are found in Antarctica and Greenland. They kind of start at a center point and spread outward in all directions. Alpine or valley glaciers, same thing, they're found in the mountains on every continent except Australia. And they happen where snowfall is greater than what? Snowfall has to be greater than what, Luke? The snow melt. And then these last few have to do with glacial erosion and deposition. So what is till, glacial till? What does that mean? Sarah?
A mixture of sediment that is deposited directly on the surface.
Good. So oftentimes that's the stuff, the sediment, the big rocks, the boulders that are carried by the glacier and left behind once that glacier recedes. Abrasion. Kara.
It's like the scratches on the ground or on bedrock or something.
Right.
That like a glacier or something leaves behind after they move through that area.
Exactly, you're right. So remember, the glacier is so massive and immense that it literally acts like a bulldozer right over the land. It just kind of scrapes it up, and it does scratch the bedrock. Abrasion is when it scratches the bedrock. Did you have a question, Jaren? You want to do moraine? All right, what's a moraine?
Ridge formed from hills deposited at the edge of glaciers.
Good, and remember in our model in the lab the other day when we pushed the ice forward, moraines formed along the sides and in the front. And what's a kettle? What's a kettle?
Make popcorn.
Well, you could make popcorn in a kettle. You could also warm up water for tea. But I'm talking about a glacial kettle. Noah.
A small depression. I don't know. It's just a small depression. I forgot the other part.
That forms
In-
chunks of ice. is
So
what-
back up a second. Chunks of ice fall off a glacier, right? Usually they can fall into the till. And what does that do? It causes a depression in the land, in the ground. Sometimes they become lakes, sometimes not. Sometimes they're just dips in the land.
Is
Jaren.
Lake Michigan kettle?
No, Lake Michigan is a little bit different because by definition a kettle is a piece of ice that falls off of a glacier. An entire glacier kind of gouged out what used to be a river, right? Lake Michigan started as a river, and that glacier that dipped down into Wisconsin kind of dug out that river, making room for when it melted and started to recede. It kind of filled up
So that's
that
why.
area.
That's why Lake Michigan is so cold.
It's cold because of its size mostly, but not because it's made from glacial ice. All right, let's look at these two pictures at the bottom. I want to know, what questions do you think I could possibly ask about this picture on the left? You tell me an example question, Sanjay.
What is happening to the rock?
What is happening to the rock? Well, okay. I probably wouldn't be that open-ended, but can someone think of maybe a little more detailed question? Isak.
Weathering, erosion, and deposition.
Oh, is this an example of weathering, erosion, or deposition? That's a great question. How would you answer that? How do you know?
Because you can see it's like there's cracks in the rock, which means it was like broken down.
And what else do you see here? Rain, which can cause abrasion, right? Which is weathering. Aiden, what's your question?
What type of weathering is happening?
Ah, which of the two types of weathering? How would you answer that?
Mechanical.
Why would you say mechanical?
Because it's rainful. Because of the freezing thawing that is happening in the rock.
It could be freezing and thawing. You have to be a little more observant and notice that it appears like this tree possibly has leaves on it. I don't know. We can't really tell, right? So it might not be necessarily winter. Might not be freezing and thawing, but we don't know for sure, and it could be. Ellie, what would your question be?
Well, you could say, what kind of weathering is it?
Okay, what kind of weathering? How would you answer that?
You could, the answers could be like plant growth, freezing, dying.
Yeah, I mean, we don't really see, maybe there's plants that are growing through the rock, breaking it apart, we can't really tell. Elena?
It's kind of Ellie's and Aiden's.
Okay,
It would ask like what kinds of weathering could occur, and then you could list all the ones that could happen based on the picture.
okay, so which ones did you list?
Abrasion, maybe plant growth, because there's like a tree right next to it and there's grass right next to the rock.
Okay,
Freezing and thawing, 'cause there's like crack in the rock.
okay,
Yeah.
alright, last one, Sanjay.
If a small chunk of the rock broke off, how would erosion occur?
Okay, how would you answer that?
The rain, the water from the rain could carry, the rock down, or if there was a slope or a hill.
Good, it could be carried by rain or water, or just by gravity too, right? Awesome questions. What is a possible question I could ask you about this diagram on the right? Rihan?
How did B cut off from A?
Okay, that's a pretty detailed question, but do you wanna answer it? How did B cut off from A?
Sediment from a meander built up and then created a kind of a wall.
Okay, so let's talk about this part of the meander for just a second. The inside of the meander is in a river. Is there deposition happening there, or is weather happening there? Think about the flow of the river. Okay, it doesn't really matter which direction it's flowing. Where does the water have to go a further distance? On the outside of the bank or on the inside?
Outside.
On the outside, right? It has to go a further distance on the outside. Therefore, that water actually flows slightly faster. Because it has to go a further distance, it flows faster. So, faster flowing water is going to create what over here on the outside of the riverbank? Weathering or deposition? Weathering. It's gonna basically weather and erode at the same time. So this part of the riverbank gets weathered a lot faster or eroded a lot faster. Ooh. Let's try that again. So weathering and erosion happen quicker here at point A. What happens here on the inside of the meander? Deposition or erosion? Jaren? Yeah, what happens is this gets slowly built up. More and more sediment gets deposited. This gets pushed back further and further and further and further. And eventually, that water just takes the shortest path and it eventually gets cut off by all this deposition. And becomes a what? What is point B? What is B pointing to, I should say? Elena?
An oxbow lake.
Yeah, that's an oxbow lake. Any other questions you could think of for that diagram, Sutton?
What is B pointing to and what is A pointing to?
Oh, good. So what is B pointing to?
Oxbow Lake?
And A?
Meander.
Meander. Good. Any other questions about that? Noah? No? Luke?
What is A, what is B, and how are they connected?
Okay. How would you answer how are they connected?
I would say they're connected because, Knoxville Lake was a previous meander that cut off from.
Awesome. Great job. Any other questions about the study guide? We're gonna play Kahoot for the last bit of time, so take up your Chromebook.
Me too. On the celery.